Hello everyone, Jonathan here, and in this final video in the Advanced Laser Defender series, we're going to finish creating the side guns power-up on our player. And what are we going to be doing? We are going to be randomizing the drop chance, so the enemy ship has a chance of dropping either a health pack or this power-up, and this is going to get kind of mathematical. It might seem like it's going to be fairly easy to do, but this is going to be a lesson in randomness and weighted randomness, which can be fairly challenging. In fact, I had to come up with a good method to do this, and I'm going to share that with you now. Also, between making the last video and this one, I did implement just a few quality of life changes. Just some sound effects, particles when you get the gun power up, and when it gets destroyed as well. I'm not going to show you how to do any of that stuff. I've shown you how to do basically the same thing in similar videos, so you are very capable at this point of implementing all of that on your own. So let's get into the randomness part. So we're already dropping the health packs on our enemy behavior script, so we're just going to continue with that script. And number one, right at the very top here, where we declare a public float chance to drop power up, number one, I'm going to change this to an integer because we're really not going to be dealing with decimal places, and I might have to change something down below too. But I'm just going to copy this line of code, and we're going to put another line right under it, which is going to be very similar. So it's also going to be a range where it's going to be a public int, but in this case we're going to put the square brackets so it's an array. And instead of being chance to drop power up, we're going to call it a good name, chance for specific drops. Because now what we want to do, first of all, we want to roll to see if we're going to drop a power up. And then once we roll to see if we drop a power-up, we're going to want to roll to see again which power-up we're going to drop. And if the items were similar, it would be fine. We could just have a 50-50 chance of dropping either a health pack or a gun power-up, and that would be fine. But we want gun power-ups to be a little more rare than a health pack. So for that, we're going to have to do it slightly differently. Also, I'm going to delete this here, health pack, and we're going to create another line under here and call it public game object, and this is also going to be an array, a game object array, and we're just going to call this, oops, not power sup power, power ups, plural. Okay, and that's going to break a few things down below because it's no longer, here it is, so this word, just for now, I'm just going to put power ups square bracket 0, and that's basically going to be our health pack. Anything else? Is anything else broken? Int roll, that's random. See, I used an integer here for the roll, but I used a float up above. That's why I wanted to convert up above to an integer. Okay, I think that should make sure I save here, and I think everything should be working now. Okay, so I'm going to click my enemy script and scroll down. Where is it? Yes, so okay, we have a new array here, chance for specific drops, that's good. And we have a different array for power-ups. So these should be equal. I'm going to make them both size 2. And it's asking for what are we going to put in here. Oh, one other thing I did while in between making the videos, was I turned this guns power-up into a prefab. So if you haven't turned into a prefab already, please do so, and then you can just remove it from the scene. Okay, so now clicking back on our enemy behavior, we are going to add those two game objects in. So the first element 0 I want to be a health pack, and element 1 I want to be the side guns power up. And over here, this is going to be our percentage drop chance. So I'm going to make it slightly higher for playtesting purposes, but I'm going to give it a 60% chance of dropping a health pack and a 40% chance of dropping gun power up. And like I said, this is too high a discrepancy. I'd rather make the guns power up something like 10 or 15%, but just for playtesting. Okay, so let's go to where we are rolling. So right now we've been rolling for a game object, new health pack. Is it going to drop or is it not? Plain and simple as that. We're not going to be necessarily dropping a health pack anymore. So let's go ahead and give that a more descriptive name and just call this new power up. And now, before we can declare, we're not gonna just decide here power up 0. What we're actually going to do is create a new line of code above this, and we're going to say game object, give it a name, chosen power up is equal to randomize power up type, and open close parentheses, semicolon. So it's going red because we haven't created this yet. This is going to be a new method that we are going to create specifically to randomize which power up is going to get chosen. And here where it says instantiate power ups, we're going to put here chosen power up. And once we create this, this will be our method for determining which power up is going to drop. Confused yet? I hope not, because it's going to get a little more confusing. So below here, I'm going to go create a new method, and this is going to be a game object method, and this is going to be the randomize power up type. Okay, and this is no longer red because now that's created. It doesn't do anything yet, but it is created. So right away, we're going to create the game object that we're going to be returning, and in this case, I'm going to call it game object drop type. And by default, when we're returning something, it's best to give it a default value. So in this case, I'm just going to give it a default value of null. I'm going to warn you of something right away here. This is a mathematical randomization thing. I came up with this method on my own, but this is not what I'm best at within coding. So the solution I came up with and I'm about to show you does work. However, it may not be the best way of doing this. So if you're able to come up with a better way of doing this, please feel free to share. But in the meantime, you can follow along with my solution here for randomizing that does work. Okay, so we're going to create a for loop, and I've shown you how to do this in a previous video. So we're going to say for int I equals 0, and then we're going to say this loop is going to run as long as I is less than a chance for specific drops.length. So this is going to run for the length of our array. So if we want to add more power-ups later, we don't have to change anything in the code. That's the beauty of this. And then each time the loop runs, increment I by 1. And open close squiggly brackets. And just like above, we have an int roll. So I'm just going to copy this. This is going to be the same. So we're going to be rolling, but we're going to be handling the rolls differently now. So what we're going to do, let's go down a couple lines here, and we need to think about how can we give this a weight. Well, this is why we're putting this in a loop, because I want I to have a chance to run and go through a selection process for each of the values. So we're going to say if roll is less than or equal to chance for specific drops at position I within the array. So it's going to go through and check both conditions, maybe. If it does this, then we're just going to break the loop. Okay, and we're basically so let's go through this again here. The loop is going to run one time, and it's going to check whatever percentage we put at our health pack value first. And if it meets that condition, it's going to break the loop, and I is going to have a value of 0. If it doesn't meet that condition, it's going to check again for the second item, and if it meets that value, it's going to break the loop, and I is going to have a value of 1. So outside of the loop, what we can now say is drop type is equal to power-ups at position I. And you're going to see right here that there is a problem, and I've done this intentionally to show you, that we can't just use I outside of the loop. I is declared for the purposes of the loop. So what we need to do is create a second variable here and call it int, I'm just going to call it int temp, and I'm going to give that a default value of 0. And inside here, rather than just breaking it, we're going to say temp is equal to I. And now in here, we're going to say power-ups at position temp. And all of a sudden, it's not red anymore. Next, we're going to just end this and say return drop type. Now, this is partially going to work, but I'm going to forewarn you right away that dealing with loops can be very, very dangerous. And I'm showing you this way because if we ran this right now, there is a chance that the program could crash. Because we're going to be rolling to see if our roll is less than the percentage chance we've given it. But right now, if you look in Unity, we've given it a percentage chance of 60 to drop a health pack and 40 to drop a guns power up. But what happens if we roll an 80? Well, it's not going to meet either condition in that case, and that could cause some problems. So we need to check for that condition too. What if it rolls something higher than we've specified? And this is why I'm saying this might not be the best way of going about and doing this, but I made some fail safes here just in case. So next, we're going to say if drop type is equal to null. So basically, if we've rolled an 80 and we haven't chosen either a health pack or a guns power up, then it's going to run this if loop. And in this circumstance, what I want to do is randomize the power up type again. So basically, run this loop until it does roll an accurate number and it can select a power up. But enough typing random code. Let's actually test this out and see if it works. And praying I don't crash the program at the same time. I didn't get any power-ups there. Maybe I should increase the drop rate for testing. So I'm not dropping anything right now, so maybe the... Oh, well actually here's why. When I reset these variables, there was no drop chance. So let's make that a 40% chance to do some drops. And let's die before I have that chance. Okay, chance to drop power up. I'm just gonna make that, oops, it's way too high. 50% chance to drop power ups. So let's actually test this now. Okay. That's working. But I want you to see something. There is, because I tested this already, and I know there might be a problem here. I'm gonna just set these values lower, just for testing. Make these 25 or 26 and 8%. So these are very low values. So, but that's okay. What happens if we're constantly rolling high numbers, 80, 70, 60, 50, and we're not meeting either of these conditions, and the loop just keeps on running? Okay, did you see that? Did you see how the program froze there? So in the console, what we've got is a stack overflow exception. And basically, this just means your loop isn't infinite, but it's running many times, and it is slowing everything down. And that's just a bad practice. So we want to make sure that we're not getting a stack overflow exception. So here's my solution for that. We're already checking to see if the drop type is null, then we randomize this. But if what I want to do is just have a default, an out. I want to say we're only going to allow it to randomize the power-up type a certain number of times, and then by default, if it hasn't selected anything by then, just give us a health pack, just so we don't get caught in this really long loop. So in this case, what we're going to do is go up here to the top and say private int failsafe. Okay? And now where we go to roll for the first time here, where are we rolling? Rolling for power up. Yes, we're going to declare, because every time a power up drops, we want failsafe to start at 0. So failsafe equals 0. And now within our randomized power-up type, we are going to, rather than just infinitely randomize it, we're going to increment failsafe by 1 each time this loop runs. And now we're going to say if failsafe is greater than or equal to 3, really it should just be equal to, but this is just giving our failsafe a failsafe, just in case something happens and the loop runs 4 times and it doesn't catch it. I don't know, it's just a good practice. If it runs more than 3 times, then we're going to say debug.log preventing stack overflow breaking the loop. And now we're going to assign temp to 0, which is our health pack. And now we're going to break the loop. And then we're going to write an else statement if we're still within our testing period. Then we're going to randomize the power-up type. And now, if we save this and test it out again, even if we have really, really low values, and our failsafe should take into account what's happening if we're rolling too high. There we go, preventing stack overflow, breaking the loop, so our program isn't freezing, we're only allowing the loop to run 3 times, which is fine. And we're getting these power-ups. And you can see here that if I increase these numbers now, I want 50% chance for the health packs, or a 10% chance for this. You should really try to make these numbers equal 100. So actually, let's do that. Let's make these numbers equal 100, or 75% chance for health pack, 25% chance for the other drop. You have to play around with this for a number to see for sure that it's working, but it mostly should be. We should be really getting our chance here to get the health packs and the gun power-ups. Well, that's basically all I have for these Advanced Laser Defender series videos. So I thank you very much for watching. I hope you've been able to follow along and mostly understand what's been going on. But if you haven't, please let me know. If you have, let me know. Upload your games, share them in the comments. I'd love to see your version of Laser Defender. And that's pretty much it for this. I'm just going to make one final wrap-up video, but thank you very much for watching, and I will see you in the future.